Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Welcome back to the Reliability Matters podcast. I'm so glad you're with me today. This is episode number 98. As I said in our previous episode, we're getting very close to episode 100, only 2 episodes away. For our 100th episode, we're going to do something we've never done before. Our 100th episode will be broadcast live. It will be broadcast live on LinkedIn and YouTube on July 26th at 10 a.m. Pacific. We'll replay clips from several of our prior episodes and hear a few comments from some of our past guests. As we creep ever so close to episode 100, once again, I'd like to thank both my guests and you, the listeners and viewers of this podcast, because, as I said before, without all of you, I would just be a talking head, and Lord knows we have enough talking heads these days. If you're watching this on YouTube, click on the subscribe button and click the bell icon to be notified when new episodes are released, including our 100th episode. If you'd like to watch our 100th episode on LinkedIn, just follow me on LinkedIn. Today, we're going to return to the popular subject of solder paste. My guest today is Jen Fijalkowski. Jen works for AIM Solder. Jen obtained her Bachelor's of Science from the University of Rhode Island in Chemical Engineering and is a certified Lean Six Sigma Green Belt. Prior to her role as Technical Marketing Engineer, she interned as an SMT Process Engineer, where she analyzed various reports regarding solder paste printing, and she co-authored Comparison of Aperture Designs, Solder Paste, Nanocoatings and Print Inspection Systems, quite a title, published in Circuits Assembly magazine. I'll post a link to her article in the show notes. If you're watching this episode on YouTube, just click on the Show More button right down there, and you can get that link. If you're listening to this podcast on your favorite podcast app, just click on the show notes. Jen also produces a video blog titled Line Down, where she discusses common questions about solder paste best practices and, most importantly, how to avoid solder paste-induced line down situations. Now here's my conversation with Jen Fijalkowski. Hey Jen, welcome.
Hi Mike, thanks for having me.
Of course.
Thanks for the introduction.
Well, of course, and thanks for agreeing to spend the next moment of time with me and talk about probably the world's most interesting topic, solder paste.
My pleasure.
So, before we get into all that, what attracted you to the electronics industry, and maybe even more specifically, the material side of the electronics industry?
So I guess I'd swap those questions because initially I had an interest in materials. As you said, I studied chemical engineering at the University of Rhode Island, and I always had an interest in how things are made, what bonds change the mechanical reliability of certain objects. So I was always interested in how and what things are made of. The electronic side came a few years after I was already studying chemical engineering. And I had my previous boss introduce me to a circuit board. So as a chemical engineer, electricity is a bit, distant from what we do with chemical engineering and chemical processing. So when I first saw a circuit board, in front of me saying, this is something you should be interested in, I was a bit hesitant. But then I realized, there's so much metallurgy and plastics engineering, process engineering, material science that goes on in making all of our favorite electronics that it really drew me as something that is not only relevant, but something that's not really talked about, kind of like a niche industry that affects us all. So that's what really drew me in. And then I just, everything I learn, it becomes more and more interesting because this is a growing industry.
Yeah, I think it's not often one can sit in a room filled with civilians, people not in our industry, and point to 200 items that we made, that we had our hands on it in one form or another, right? I can't think of, outside of electronics, I can't think of, and maybe the food industry, that is so omnipresent, right? It's pretty much everything you see is made by us. And if you didn't sell the paste, you know the person who sold the paste. If I didn't clean the board, I know the people who clean the board.
Yeah, exactly.
It's
and it can go anywhere from your iPad or something all the way down to like your remote control. It's everything and everything in between.
Yeah. It's definitely I think a fascinating industry, and it moves at kind of at the speed of light. It changes so frequently, which keeps us all on our toes. And for me anyway,
Exactly.
one of my most frustrating and most exciting parts of this industry is its pace of change. Want to talk about solder paste?
Let's do it.
All right. So among other things, before we get into the actual paste stuff, but to do with paste, you produce a video series called Line Down. I love the title of that series because no one wants their line to be down.
Yeah, right? It's really catchy.
Yeah, exactly. It got my attention. So it's been said by many, probably accurately, that most of the reliability problems start at either the paste or the printing process, right? That is kind of the genesis of many issues and many successes, right? It's you make it or break it at that point. There's lots of other things that could go wrong later, but a lot of the reliability issues start at that process. So you're kind of at the beginning of the food chain in terms of assembly. So tell me what drew you to, or what was the genesis of the Line Down series, and what made you say, I'll get in front of the camera? Was that your idea? Were you voluntold? Was that an assignment? Or something tells me, based on your enthusiasm, as evidenced by the videos, that maybe you wanted to do this.
Like, I guess it's something that, I don't know, I wasn't as afraid to do it because we have pictures and photos of us all over the place, and I presented before, so why not capture it in a video? And we knew with AIM that's something we wanted to move towards, especially being virtual, is that people are a lot more receptive to people speaking than just an image. So that's what drew us to the video. As for the content, we knew that we also wanted to answer our customers' questions, and to also get information that we have available on our website or in some of our supporting documents, but have them, have them be out there in a reminder. So these videos kind of serve as hey, we have advice on how to problem solve these situations that are already available, but here it is. Let's repackage it. Let's remind you, and let's prevent your line from being down.
Yeah, I think also, I assume this is intentional. It seems to be presented on a basic level. I don't think you're not digging for gold. You're not building mine shafts and going super deep technically. And my experience when I present papers is I purposely keep it a little shallow. There are plenty of engineers out there that'll present molecular level stuff, but I think there's a good percentage of the audience that maybe doesn't have a good handling of the basic, of good knowledge of the basic, and they're kind of afraid to ask that. So to watch videos about how long to keep it out of the fridge before you use it, and stirring the basic stuff that many people might forget, or maybe if you're young and you just graduated college, you know how electrons work, but you may not know the amount of time solder paste should settle, or squeegee pressures, or those are things that are kind of learned at the trade level, so either at a trade school or on the production floor, not necessarily in a university setting. So I think that those efforts are well founded to kind of start at the basics, presume nothing, kind of a beginner's mindset. Was that intentional?
Yeah, I think it was intentional, or I know it was intentional for two reasons. One being that we're living in a time where everyone has a short attention span. So we are trying to keep these videos to a minute or below. So as people, scroll and watch the video, that it only takes a minute for them to get the information that we're trying to get out there, and then there's a link for more detailed information. And I do agree that, there's a wide range of people that can go into this industry, and to start from the basics, we're trying to do a service to people to just remind them of where to start. And if they want to look for more information, that's when things become more complicated. We get our tech people in or have presentations. But I think that there's as you agreed, a wide audience of people who are just looking for the basics and in a very digestible format.
Yeah. It's not what's said, it's what's received, right? So that's important. Okay. What are some of the common, speaking of mistakes, lying down, what are some of the common mistakes that you see from your perspective that continue to be made when it comes to solder paste? Mistakes that could lead to a line down or a reliability issue in the future?
Well, I think, as we were saying before, a lot of people get caught up in the molecular aspect of things and get really focused on, say, like the printing side, because there's so many like levers and buttons that you can press, so many different settings you can adjust, that people get really distracted by printing aspects, when really we see in the field that a lot of defects that can be prevented really come from shipping and handling misusage or not following the proper instructions. And so that's been a theme in a few of our episodes, is just how do you allow paste to reach room temperature? You don't apply heat, and you don't use automated mixers, and just very simple things like, you think about baking a cake. You want to make sure your eggs are good before you mix them in and put them in the oven. It's kind of before the first step. That's where we see a lot of mistakes being made, especially because this is an industry that uses our material worldwide. There's various seasons, and we're shipping all across the world. So it might seem like you only need to worry when you get your paste, but you really need to think about every single step that it endures.
Yeah, I've had the privilege of traveling around the world, several times, and I've been to a lot of production facilities, assembly facilities, and they're not all super climate controlled. They're not all what we may be used to from our local shops. Some of them are a little on the rough side, and that you're right. That puts your product in a variety of situations. Products are tested in a lab, but they're used in the real world. So I'm sure that has to be taken into account. How long they leave a jar out of the fridge probably partially depends upon the ambient, climactic environment around there.
Or something simple as mixing old paste with new paste. Like, that's something that, we don't recommend, that I'm sure people do because they think that they're saving money or, reducing storage in like a fridge or something like that. But, it's our job to advise the best way to use our product. And we see that that's the first step in having a successful process.
How about putting things back in the fridge, opening jars, letting them settle, mix them up, use some of it? Do we put it back in the fridge at that point, or do we, once it's out, we keep it out?
Yeah, once it's out typically. And you should reseal it if you're finished with it, but it shouldn't be re-refrigerated after it's already been opened.
So typically, what's the shelf life? Once someone cracks open the jar, scoops out what they need for a production run, and there's stuff left in the jar, the clock is ticking at that point, right? Because it's not going to go back in the fridge and stop time, pause time. What typically is the shelf life once opened and exposed to ambient temperatures?
So we do recommend that if you're going to open your jar of paste, that you try to use it all in a single day. As you said, the conditions of the manufacturing floor will also alter how long the paste is viable for. So in ideal conditions, we would say, use what you can within that day.
Yeah, that makes sense. How long? Well, the day. So don't put it back on a shelf and use it a week later. That's
yes,
typically a bad idea.
Exactly.
Right.
Mm-hmm.
There's well, from your perspective, let's just kind of start at basics again. What's the most common solder paste type used today?
So I would say no clean solder pastes are definitely the most common, with lead-free alloys. At AIM, that would be M8, like SAC 305. That's probably our leader, because everyone likes to save the cost of cleaning at the end, and we know that no clean paste should be able to reach IPC SIR reliability standards without cleaning. So if you can take that step away, we found that in the industry that's been a very popular choice. And also lead-free alloys are the move recently, or not recently, but have been in the industry for a while for safety reasons and because they can do most jobs, right? Like they can serve most industries and applications, and we see typically type 4 still being used.
Okay. So there's a lot of talk. I hear a lot of talk. I'm not in the materials business. I'm in the equipment business, but I do hear a lot of talk about specialty solder paste, particularly these days. Low temperature solder paste, low voiding solder paste, high reliability solder paste. And the high reliability one gets me because I assume all solder pastes are kind of high reliability. So it makes me wonder, I don't think you'd ever sell anything and label it low reliability, right? But there's solder paste and the high reliability solder paste, low temperature, low voiding. Let's begin with the so-called high reliability solder paste. What are the differences between a regular, off-the-shelf SAC 305 and something kind of billed as or marketed as a higher reliability paste? What are the differences in the paste, and what applications would you see that paste going into?
Sure. So we define high reliability applications as those that use the end product in harsh environments. And so I guess the question is then, what is a harsh environment? And that is dictated by the end user, but we believe that high reliability products are mostly used in aerospace, military, and avionic applications. So those applications are pushing requirements beyond just day-to-day usage. So it's not like your computer remote that you use every day. It's something that's going to go into atmospheres that are atypical. So wide temperature ranges, different humidities, and different like mechanical requirements are what make high reliability products different than normal ones. So some testing that you do to products to ensure that they will be able to endure these harsh environments are thermal cycling tests, thermal shock tests, stress strain tests to look at the mechanical reliability of the joint, and also SIR testing in different humidity and temperature settings. So it has both to do with the paste chemistry, so that you're preventing dendritic growth in those extreme environments, and also the alloy characteristics, so that if you're the product's vibrating or it's being dropped or changing environments very rapidly, that it will maintain the quality of the solder joint. So really high reliability is just pushing products to their endpoints, really.
Yeah, that makes sense. Let's talk about low voiding. Well, let's talk about solder voiding in general. There's two camps, and I've heard both on this show. Those that say that voiding is a real issue and we need to decrease voiding to as close to 0% voiding as possible. And then there are those that say voiding is overrated. We can get away with 80% voiding, just 20% contact. There's enough thermal dissipation and enough bonding from a current standpoint, and enough adhesion that from a bonding standpoint that nothing's going to fall off, current will flow, and nothing's going to overheat. It's all overrated. I've heard both on this show, and I'm sure the answer is a little bit case dependent, but it's probably somewhere in the middle. I'm sure it can be. We probably don't need 0% voiding, and probably 80% is too much. So somewhere in the middle. But I suppose it depends on the cost of failure and the expected life of the product and the climactic and use environment, and whether it's going into a shock, a vibration and shock condition, or on a spacecraft or something like that. But what are the characteristics of a low voiding solder paste? Does it have a different reflow characteristic? Does it require a narrower tolerance within the reflow profile? Does it print differently? What are the physical characteristics and in-use characteristics of a low voiding solder paste versus a standard solder paste?
So first we'll talk about voiding in general, what it means to the industry and to the EMS provider. So We know that with IPC, the requirement for 6.1.5.3 is that the total volume of voids needs to be less than 50% or less. So that's just the standard that we need to follow as an industry. Whether you think you can get away with 80% or 30%, that is dictated by the person buying the product at the end, who is going over the quality of the product. So that's what we have to work on, right? We have that 50% maximum, and then beyond that, as you said, it really comes down to like case by case. What are the requirements dictated by quality? So how we have adapted we have a new low voiding, no clean solder paste called V9 at AIM. And what we have done is we have both made sure that our printing capabilities with this new paste are equal to that or greater than that of M8, which is one of our most well-studied pastes. So we don't want to compromise any other characteristics by also introducing this low voiding characteristic, which includes having a flexible reflow profile setting. So, no matter what profile you use or tweak it to, it's still going to have an incrementally lower voiding percentage than our M8 paste or some of our competitors' pastes. So it's really not about like taking away any other characteristic by inputting low voiding characteristic, but getting everything all at once.
Yeah, like many things in life, there are many products that deliver a specific advantage, but also carry a disadvantage. I crack up when I watch commercials for pharmaceuticals, for example. If you have this problem, take this prescription, and then they list 25 things that could happen as a side effect. Suicidal thoughts and excessive gas and just the horrible stuff that makes you wonder. You're solving one problem, creating 20 more, potentially. In this context, in solder paste, when there's these specialty pastes, and we'll talk about low temperature paste in a moment, but say a low temperature paste or a low voiding paste or some high reliability paste, clearly there are specific advantages. Do they also come with some downsides, so that maybe unless you specifically need it, one might want to avoid that particular attribute because it's harder to reflow or it's harder to print, or whatever. I don't want to put words in your mouth, but are there flip sides to some of these? Are there decisions that need to be weighed when one implements a more specialty paste?
I think that when you're introducing a more specialty paste, there's going to be less research conducted on it being used in different applications just because of the fact that it's been used less. So there are going to be some, new applications or new uses, new material combinations, and that's just a symptom of trying something new. But I think, something that this podcast does, and I think that's something that other, industry organizations try to promote, is us sharing our findings, right? So when we say like, oh, I'm using this new specialty material, and when I use this surface finish, so it's a bit different than what I'm used to. I think it's the responsibility of everyone in this industry to kind of like share our observations for the better use of the product in the long run. So I know it's a market, we're all trying to make money, but I think the sharing of knowledge is something that won't make or break anyone else's bank.
Yeah, I agree. Let's talk about low temperature solder paste. Ironically, kind of an oxymoron, low temperature solder paste is a hot topic right now. So what applications benefit from low temperature solder? And then we'll get into some of the physical characteristics of that. But who's buying low temperature solder and why?
Sure, you're right. Low temperature solder is a hot topic these days, and for a few reasons. So the reason low temperature solders are being implemented, or one of them, is because we're introducing new component materials. So the plastics and different components, whether you want to save money or have different characteristics to the component, something that's changing is also the melting temperature of that plastic. So I've actually seen it before firsthand, where you run a board at a stack profile or something, and then one of your through-hole components is melted. And that's just not, you're not going to be able to use a product like that. So that has been one of the motivations to switch to a lower melting temperature solder, so that the peak reflow temperature is below the temperature that melts the plastic. So that's one motivation. And another motivation is also just energy consumption. So as we know, we use these massive reflow ovens that are like the size of small boats. And if you can reduce the overall reflow profile, the entire temperature of that oven, you're going to be saving a lot in energy. So those are probably two of the main motivations to move to low temperature alloy.
We did a study with a DOE with our friends and colleagues at Foresight, which is a failure analysis laboratory in Indiana. And the hypothesis was on boards that are going to be reflowed that with no clean paste and not be cleaned. What are the SIR ratings if the reflow profile drifts beyond what's expected? So in this case, we use a SAC 305, no clean paste. The lowest acceptable or the lowest recommended reflow temperature was 230 degrees C. That was the lowest. And so we ran boards at 230. And then we ran another set of boards at 2% less, and then another 2% less, and then we got to 5% less. 5% was 218 degrees. From a solderability standpoint, nothing fell off, and we didn't leave any sludge. It wasn't sitting there sludgy on the board. We had a good solder bond. The difference was when we ran the boards through SIR. At 5% off, we miserably failed SIR tests. At 100% of the peak reflow temperature, 230 degrees, it was stellar. We had super high resistivity numbers, but we had miserable fails when we drifted 5%. So that, we were able to document the correlation between reflow temperature, peak reflow temperature, and SIR results. And there's a reason why solder paste manufacturers recommend a specific a reflow temperature. One of them is, of course, you have to melt the solder. Clearly. But the other is there's all sorts of chemical tricks they're playing with the activators, particularly for no clean. The activators have to be burned off. You have to be able to encapsulate the bad actors. And there's all sorts of technology there, heat related, to be able to offer the elimination of a process step, being cleaning. So with that in mind, when I hear low temperature solder paste, I'm wondering the chemists that formulated this must take into account that if you're running a reflow temperature that's a lower temperature, they must use different types of ingredients in the flux that will burn off at lower temperatures as well. If you're going to clean the product, no problem, then I'm not concerned. But if you're not going to clean the product, if it's a no clean and not going to be cleaned, and you're going to run a lower temperature, I wonder how that is going to fall into SIR numbers. So is that a phenomenon known to you, and I assume there have steps been taken to ensure that not just you get a good quality solder joint, but also the activators and all the things that rely on certain temperatures, those expectations have been reduced as well?
Mm-hmm. So I think that the DOE you did was extremely relevant, not only to low temperature solder paste, but just, reflow in general with any type of paste. And, earlier I spoke to the relevance of the melting temperature of the alloy, but you're so right that it's a paste is half the alloy and half of the flux activator system. And that if you're using a low temperature alloy or trying to reflow at a lower peak reflow temperature, that you do need to reconsider the flux chemistry that you're using. So we at AIM actually do have a low temperature solder paste called NC273LT, which is specifically designed with low temperature bismuth bearing alloys, so that we can have successful reflow and fluxing activity at those lower temperatures, because the flux also prevents oxidation, it promotes coalescence, it does a lot more than just hold the paste or hold the powder in place while you wait for it to melt. So you're so right that you need to have a paste that not only has like the flux activation system, but also will be, still high enough reliability after the assembly is completed with preferably no clean, because that's what we said at the beginning is the most popular, right? People want to save that money. So you might not do it with a low temperature paste too.
Right. Yeah, this is, these are professionals at work. Don't try this at home, kids. It's not that easy. You change one thing and then there's 5 other things one has to consider. So it sounds like those considerations were made. Let's talk about solder paste mesh sizes for a moment. If someone's kind of new to this industry or, fresh out of college, again, we talked earlier before we went on air about universities, will graduate an electrical engineer with a great knowledge of electrons and how electrical systems work, but maybe not, how to properly stir a jar of solder paste, or, how long to keep it out of the fridge, or what mesh size one should choose. So kind of from a beginner's mindset, what are the typical mesh size, what are the typical mesh sizes that most people would use, and what factors would drive a non-typical mesh size, either a smaller sphere or larger sphere? Explain that to me, if you wouldn't mind.
So I'll explain to you the way that I was explained this the first time around. So how mesh sizes work, as some may already know, is that the larger the type of the powder sphere, the smaller the actual sphere. So in the industry right now, I would say type 4 is the most popular, most widely used, most well understood. And beyond that, how you choose to, reduce your mesh size, I learned a very basic calculation, which is called the 5-ball rule, which can motivate you to reduce your mesh size depending on the aperture size of your stencil. So if 5 spheres fit in the width of your aperture, then you could potentially use that solder sphere size. And that might be something that people have recognized before. But I think beyond that, so that could be a guideline. That's like a first step of, okay, is this something that makes sense due to like the packing of the spheres so that you can create a full solder joint. But beyond that, we at AIM have actually already done a study looking at the impact of reducing mesh size from type 4 to type 5. And we've seen a very little impact on the overall transfer efficiency and print quality just from making that change. Because we also know that, changing the printing conditions such as nanocoating the stencil or cleaning the stencil at different frequencies can also impact print quality. So there's, more than one decision you have to make when you're considering reducing your mesh size. But I think when you're looking at, much finer apertures or print deposit sizes, that's when you consider, okay, maybe I should reduce my mesh size further, kind of after you've already tried everything, I would say.
Do you recommend nanocoating for specific types of applications more than others? I don't think there's a situation where you wouldn't recommend it, but is nanocoating more recommended for extremely fine apertures or certain mesh sizes?
Yeah, so I would think that, or I know that there is an improvement seen when you use nano-coated stencils. There's an improvement in transfer efficiency and in volume deposit consistency, for sure, especially for those finer pitch features. But something that we're seeing further down the line is as these apertures become smaller and smaller. Like currently, we are actually already looking at deposits that are 100 by 100 microns. So when you're looking at that and stencils that are 30 microns thick, every single dimension you need to take into consider and scrutinize to a different degree, even the stencil coating at that point. So, as we are looking at these extra miniature devices, that's when you might reconsider and say, is the improvement that I'm seeing with this nano coating, worth the potential variation we can see in the deposit volume because it's just so small?
Right. You see a lot of applications coming across your desk. Are there certain applications that cause you to pause, like, oh my God, this one's a hard one? So are are there more challenging applications for a materials provider than others? You know, you've got your easy stuff, you got your low-hanging fruit, and then you've got really challenging things. What would those challenging things be?
I would say both from, what I see on my desk and also what I see in industry publications is actually in the automotive industry, because they're taking things from every other industry, whether it's display, whether it's lighting, whether it's, the traditional powertrain, and they're throwing it all in the car, and they want it done quickly and the highest reliability and to look the best. So when I see an automotive application coming in for, advanced technology, I'm like, okay, this is, their standards are high and we need to meet their expectations and, find out what we can find about how our products act in these new applications. So probably the automotive industry is what's collaborating the most with everything else. So
yeah, there's a lot of buzz right now surrounding the auto industry. EVs are quickly gaining market share. It's still well behind ICE cars, internal combustion engine vehicles, but they are certainly gaining market share at a historically rapid pace. In fact, industry forecasters believe that by 2040 they'll have already produced 600 million EVs, which is a lot of EVs on the road. EVs come with the potential. I don't understand why conventional cars don't offer this to the degree that EVs do, but there's no reason a conventional car can't be autonomous. But that seems to be in the realm of the electric car market, all this autonomous driving and semi-autonomous driving. With all of the electronics now that are driving systems, ADAS systems, for example, on cars that control adaptive braking and adaptive cruise control and blind spot indicators and all this safety stuff. We as drivers, and I've said this on the show before, are kind of becoming worse drivers because we're relying on the technology more than we used to. I don't literally keep my foot hovering over my brake as I'm approaching someone on the freeway because I have confidence that my adaptive cruise control using LiDAR or whatever technology it works will brake for me. At first, I would always hover over just in case. I don't look over my shoulder anymore before I clear a lane or change a lane because I trust my blind spot indicator would warn me if someone was there. So I've become kind of a worse driver relying on the technology. If that technology fails me, I could rear end somebody or I could sideswipe somebody or worse. So the electronics industry has very rapidly understood that quality is a major thing. We're making cars far better now. You're probably too young to have maybe even been around in the 70s, but I remember driving cars in the 70s, U.S. cars in the 70s, and we made terrible cars in the 70s and even 80s. We made awful cars. The Japanese came in and made good cars, and now I think American cars, European cars, Asian cars, they're all pretty similar in quality today. But they're all concerned way more about safety than they have been in the past. So what are how have the solder material providers like your company dealt with the increasing reliability demands, particularly coming out of the auto industry? They tend to have their own standards. They tend to kind of march to the beat of their own drummer. How have you guys dealt with that?
So I think, or part of it has been that the responsibility has trickled down to us. So it's not only the auto manufacturer that feels the need to keep their drivers safe, but we also know that we need to contribute to that by creating materials that keep people safe. So we do that by collaborating and being in very open communication with the auto market that we provide to, and we say, where are your standards? Like, what tests have you done that you say you need our pace to perform at a certain place that mechanically that we can try to achieve? Like, you tell us and we'll do the testing. So I think a big part of it is that we are willing to do the testing in order to confirm that our products are safe, and we do that hand in hand with the automotive manufacturers. And we're not afraid to explore our own products. And we are quite fortunate that we have a talented metallurgy team that has developed an alloy called REL 22, which has every time outperformed SAC 305, both in thermal cycling, drop shock, vibration testing, all around. So it's just about scrutinizing our own products because we understand the responsibility that we undertake by providing them in the first place.
Excellent. So without giving away any trade secrets, I don't want to have to have you tell me anything and then you have to kill me. What's the future of the solder materials industry? What direction do you see it going? Do you see any fundamental changes? Do you see just more of the same? From your vantage point, what's your view on that?
So I think that the future is going to be in diversity of products, in figuring out what works best for you, both in the alloy aspect and in the paste aspect. And I think because people have different requirements and different both for the reliability of the product and for the processing capabilities that they have in house. And in terms of, how much money they want to spend and what type of, energy, in terms of money and investments that they want to put into the product. So I think that there will be more specialty products coming out in the future. And I think sharing information on what we find on these new materials are going to be a really big part of us continuing to develop the materials and technology to, serve our society. So I think it'll be more individualized products and hopefully more sharing of information so that we can all continue to develop as an industry.
Very good. And finally, as we wrap up, in the time we have left, tell me more about the article that you co-authored. And it's got, hold on, I need to take a deep breath because it's a long title. Comparison of Aperture Designs, Solder Paste, Nanocoatings, and Print Inspection Systems. And that was published in Circuits Assembly magazine. Tell me more about that article. What were the takeaways from that article? How did you get roped into that? All of that.
Sure. So that was during my internship when I was still in university with Chris Shea, the industry consultant, and this was pretty much the ultimate DOE. So it was a great opportunity for me to evaluate so many different aspects of printing all together. And so some of the things we evaluated were stencil thickness, nanocoatings, different nanocoatings too. We looked at nanocoating that was cured on, and we looked at one that was wiped on. We also looked at various aperture designs. So for the 0402s, we did a inverted home plate versus just a radiused aperture opening. And we also looked at various solder paste too. So it was kind of like this ultimate, how many things can we tweak at once while still, being able to look at how each variable affected. We looked at transfer efficiency and volume percentage and variation as indicators for the effects of each of these variables. And we found that, reducing the stencil thickness improved paste volume deposit consistency. We also found that the cured on nanocoating performed the best. We then decided that the volume printed for the inverted home plate and the radius aperture design produced a similar volume percentage, but that we know that the inverted home plate can reduce the potential for tombstoning and midship solder ball production or creation. So it was a really great opportunity for me to work with some very talented engineers to evaluate the different variables that go into printing, and we got to do it statistically using solder paste inspection data, which for anyone who's technical, we just looked at lines and lines of Excel, and we were able to come up with some really important and impactful outcomes that I now use to guide the way I evaluate solder paste performance with AIM.
Yeah, it's amazing what you find when you look, and all that data. I'm sure half the effort was probably data mining, right? just extracting the data. It's all there. It's telling a story. It's screaming out a story. You just have to extract it.
Have a look.
Right. Exactly. Well, there's probably no one better to work with than Chris Shea as a co-author. She certainly wrote the book on that subject.
Yeah, exactly. She's great at teaching the basics too, and I think that's where I've taken a lot of my inspiration from. Is I'm like, wow, someone told it to me in plain English, so let's continue on that track.
Excellent. Well, Jen, thank you so much for agreeing to be my guest on this show. It's been a real pleasure and very informative. I really appreciate the work you do with your video series, Line Down. Where can people find that? Is that on the AIM website? Is it on? Do you have a YouTube channel going? Or
yeah, Line Down is mostly on LinkedIn right now, but it can also be found on our website.
Okay. And then again, that article that was written by Chris Shea and Jen, I'll have a link to that article published in Circuits Assembly magazine in the show notes. So once again, if you're watching this on YouTube, click the Show More button, and you'll see a link to that article. And I'll also post some Line Down links as well, so you can get some good information directly from Jen. And if you're listening to this on your favorite podcast app, just click on the show notes using your podcast app, and you'll also find those links there. So Jen, once again, thanks for spending your afternoon with me. I really appreciate it, and keep up the good work.
Thanks, Mike. Thanks for having me, and thanks for giving us the opportunity to talk about solder paste.
My pleasure. I do. That is one of my favorite subjects anyway, so I'm happy to talk about solder paste. So thanks, Jen.
Thank you. Have a good one, and congratulations on almost 100 episodes.
Thank you. You are number 98, so just two more before we hit 100. And yeah, that'll be a fun one. We're doing that one live. Which is a little scary because so many things could go wrong. So many things do go wrong, but why not? We're human, right? Why not show it?
Yeah.
So I'm looking forward to that episode. Okay, well, thanks again, Jen.
Thank you. Have a good afternoon.
You too. Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on Apple Podcasts, Google Podcasts, Spotify, and on our newest channel, Amazon Music, or virtually wherever you get your podcasts. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks for your questions and episode suggestions. Please keep them coming. Send comments to Mike at mikekonrad.com. That's Konrad spelled with a K. Once again, thanks for listening or watching. If you're watching this on YouTube, be sure and click the subscribe button and the bell icon to be notified when new episodes are released. I'll see you again in a couple of weeks. In the meantime, stay safe, stay healthy, stay happy, and of course, keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.